So the test you just took, all of these problems could have been on that test. The sine of 0 degrees. We go to 0 degrees. Here's 0 degrees. We look at the y value. It's 0. So that's equal to 0. Sine of 90 degrees. You go to 90 degrees. Sine is the y value. 1. 180. We're back over on the left. 0. 270. We're down at the bottom. It's the y, which is -1. And 360. We're back at the start. 0. Really, what those are now when we graph it. So before, it just said evaluate sine of 0 degrees. Now we want you to graph sine of x equals y. So what you're going to do is plot the point 0 degrees 0. You're going to plot the point 90 degrees 1. 180, 0. All of those are coordinate points that you are going to plot on an x and a y axis. So we're kind of undoing the unit circle and putting it on an x and y axis. We can flip these upside down. We can stretch them, shrink them vertically. We can move them left and right, up and down. Today, we are going to do everything except move it left and right. Tomorrow, we'll add the vertical shift and horizontal shift to these graphs. So the reason I do this is so you can see how it is related to the unit circle. So sketch the graphs of each. So we have on your notes, you have the y equals sine x and cosine. Now, one of them has an x and one of them has a theta. Doesn't matter if it's x or theta. It's just a way to represent an angle, a variable. It could be capital T, lowercase f, r, alpha, all kinds of different things. That does not affect anything. Yes?
So since 0 and 0 degrees and 360 degrees are in the same place, are they always going to have like the same number, or?
For the parent function, yes. Okay? Parent function, yes. But when we start shifting things, then that's not always the case.
Okay.
Could be, but not always. So yes, for the parent function. So we just filled this out. We said this was 0, 1, 0, -1, 0. So what we can do is we can plot those points over on that axis that's drawn for you. So I don't think this is there for you. Take that. Well, maybe I can't take that away. We'll take that away for right now. Okay, so you have an axis right here with 5 tick marks on it. Those are called critical values. You're always going to plot 5 critical values. We're going to be graphing 1 cycle of everything. If we graphed 2 cycles, there'd be 10 critical values. Okay, so just depends how many cycles you're going to graph. We're going to graph 1. So we're going to start with this first point right here, 0 degrees. Now, this is still the x, and this is the y, just like a typical table. You do not have to draw a table every time. I just put that table there to kind of help. Now, whenever we get our 0 or 0 degrees written down, we want to draw our y-axis. So our y-axis is right there. We can label that y. We can label this x. And at 0 degrees, the y value is 0. So we plot that point. Our next point is 90 degrees. At 90 degrees, y equals 1. So we need a 1 up here. At 180 degrees, y is 0. To 70 degrees, y is -1, so we need a -1 down here. And at 360 degrees, y is 0. So those are considered the 5 critical values: 0 degrees, 90, 180, 270, and 360. And we'll talk in a little bit about where those numbers come from and how they can change. Okay, but that's the parent function. Now, if I were to graph, I don't want you to graph this, but if you were to get your calculator and type in y equals sine of x, okay, and graph that. So your normal graph, zoom 6, looks like that. Okay? If we extended the window to go to 50 and we graphed it, it keeps going on and on forever. The graph didn't change, we just saw more of it. So this is from like -10 to 50. Notice it keeps going. If we kept increasing that window, it would keep going forever. So When we graph this parent function, this is not the only part of it. It goes on and on forever. We just have to come to a stopping point at some point. So we graph one cycle. So what that looks like is it's a curve. Think of this top as, think of it kind of like a parabola. It comes down, and then this bottom comes up. That concavity is very important. Okay? I do not want to see this, this, this. That won't get you any credit. That green graph right there, no credit. It's got to have the correct concavity when you draw it. It does not have to be perfect, but can't be straight lines, and it's got to have the right concavity. And by that I mean we also can't go here and do something like this. That's not right either. Okay? We don't want to go so much that it's not even a function anymore. Okay, so just nice little curves. If you're concerned that yours is not good enough on homework days, ask. Testing quiz days, I won't tell you. You can't say, is this good enough? I won't tell you yes or no at that point.
Excuse me, it's just me. Olivia H.
So this is considered the parent function of a sine graph. Notice we started in the middle, so there's three places. There's low, middle, and high. Those three words you're very familiar with. So sine starts in the middle. It goes high, middle, low, back to middle. You never skip a middle, so high always goes back to middle. Low always goes up to middle. Middle is either going to go high or low, and you go in that order. And you would keep going on and on and on forever. It keeps repeating over and over again, so it's called a periodic function. Okay, whether you know that or not, it's not a big deal. Another word for it is sinusoids. So sine and cosines are sinusoids because they continue on and on forever to the left and the right. We are only going to graph one cycle. The other thing is the directions have to tell you. Why did I choose to use degrees? Because the directions said use degrees. That's how I know. Okay, whatever the directions tell me to. Now, tomorrow when we start adding the horizontal shifts, you have to figure out if it's degrees or radians. But today, the directions have to tell you. All right, then we have the cosine graph. So y equals cosine theta. That theta is no different. This is still the x values. These are still the y values. Going back, yes?
Why did you use theta?
Just because. Yeah. They'll be changed, just like sometimes we use x and sometimes we use capital T and sometimes we use R and D and L. Same reason, it just mix it up. You've got to be able to recognize different variables there. It does not mean anything different, okay? Theta versus x means nothing different. It's still just a placeholder for an angle. All right, so cosine of 0 degrees, again, think about our unit circle. 0 degrees, cosine is equal to 1. So 1, 90 degrees is 0. Cosine of 180, negative 1. Cosine of 270, 0. And 360 is 1.
Oh, they're inverses of each other.
No. Don't say that.
No, they're not. They kind of look like that.
Okay.
The 1 is replaced by the 0.
Right, but saying they're inverses of each other is not mathematically correct.
Oh, it's not.
No. Because we are going to do the inverse of cosine and the inverse of sine.
Oh.
So we will do those. Okay? So we're going to plot these just like we would before. I'm going to go ahead and fill in my x-axis. You can do them one at a time. And 360. So at 0 degrees, y is equal to 1. Plot that point. At 90 degrees, y is 0. At 180, negative 1. 270 at 0. And at 360, positive 1. So now I start here. Now this one's a little trickier for some people to draw because we aren't just going to connect the dots. It's still got that same curve to it. We're going to curve down this bottom still. Kind of think of it like the bottom of a parabola. Think of the tops as like the top of a parabola. This concavity right here is important, okay, that it curves. Because remember, if we were to keep drawing this, it would come back down right like that. You do not want to start up here and finish up here. That is not right. This graph cannot be bigger than 1. It cannot be smaller than negative 1. So that light pink right there would not get you full credit. It would be completely wrong, But you get some points taken off because that is not correct. So you either stop at one cycle, or if you want to keep going a little bit to help you draw that curve to realize that it comes back down, that is fine. Fine with me.
Is the line for our y-axis, does it have to be right over 0? Or
Yes.
can it be a little,
Nope, has to be at 0. Today, it's always going to be that first critical value. Tomorrow, when we start shifting, it's going to be wherever 0 is. Okay, so your y-axis is the line x equals 0, always, and no matter what problem you're doing, trig or no trig. The y-axis must be on 0, always. Now, this says what would change if we used radians? I think I just added that question for myself. I don't think that's actually on your notes. Okay, but what if I used radians? What would change? The 0 degrees would become 0. The 90 degrees would become pi over 2. 180 would become pi. 270, 3 pi over 2, and 360, 2 pi. Nothing else changes. The cosine of 0 is still 1. The cosine of pi over 2 is still 0. The cosine of pi is no different than the cosine of 180. It's still negative 1. So whether we're doing degrees or radians, it has no effect on the graph itself. It affects the x-axis. Doesn't affect the y-axis. The y-axis is just values. The y-axis is like the sides. The x-axis is either going to be in degrees or radians. Those are your only choices. All right, so now we have the parent function of the sine and the cosine, both of those parent functions. So we're going to do, we're not going to do any shifts, but we're going to do some amplitude changes, some vertical stretch and shrink, and then some other changes also. All right, so terminology. This page is very important. If you're not going to print any of your notes, print this page only, because it is super important to know all this. Just like the last unit, it was important to know what reference angle meant versus quadrantal versus coterminal. All those different things were important, and they're still important. Don't forget anything from Unit 1. Still kind of have to know that stuff. This still going to carry over to Unit 2. Unit 2, we're going to go right back to the unit circle a lot more. So first thing, cycle. Definition of a cycle, it's from one point to another until it starts repeating itself. So what we did here is we graphed one cycle. Notice we were up high, and we went middle, low, middle, high, and then it was going to start repeating itself. Middle, low, middle, high. Middle, low, middle, high. Middle, low, and it just keeps going on and on forever. So this blue is one cycle of a cosine graph. The period is how long was that cycle. So the period is what was the beginning x value to the end x value. What was that distance? So it was 360 degrees. So the period of the cosine graph is 0 to 360, which is 360. It will either be in degrees or radians. Now, 10 degrees is degrees. 10 with no degree symbol is a radian. 10 pi is a radian. 10 doesn't mean 10 pi, right? We can all hopefully say that 10 does not equal 10 pi. 10 doesn't equal 30 something, right? So this is a radian. This could be a radian. Both of those could be radians. You don't have to put a pi. Don't just add a pi to things because you think it's a radian. What makes a radian is there's no degree symbol. So if we were in red, the period would be 0 to 2 pi, so it would be 2 pi. So that's going to be very important. When we graph, when we start changing, because we're going to start changing, there could be more than one cycle in one rotation. There might be 2 cycles in one rotation, or 3 cycles, or 4 cycles, or pi over 7 cycles. Next thing, the amplitude. The amplitude is like your vertical stretch and shrink. Like a parabola, y equals ax squared. That a stretches or shrinks it. It also flips it upside down. The one thing to know, though, when we're describing, like, what is the amplitude? Amplitude is a distance. If something is a distance, it cannot be negative. So when I say what is the distance, or what is the amplitude, it's always just the positive. So if I said y equals 3 sine theta, or y equals negative 3 sine theta, this is where we get the amplitude. No matter if it says 3 or negative 3, the amplitude is still 3. The negative just flips it over that middle axis, which we call a sinusoidal axis for sine and cosine. It's just the middle. So we have high, middle, and low. The middle is the sinusoidal axis, and that's where things get reflected over. This note right here about sine and cosine have an amplitude. Those are the only graphs that have a distance from the middle up and the middle down. We would never ask you the amplitude of a secant, a cosecant, an arcsine, an arccosine, a tangent, cotangent. None of those other graphs we do, we would ask for the amplitude. Now, that doesn't mean they can't be vertically stretched or shrunk. That can still happen. It's just not called an amplitude. Okay? So again, this page, including this right here, very important page to keep handy right now. So y equals A sine B theta. A is your vertical stretch or shrink. It's where you get your amplitude. Just know that it can't be negative. If it asks for the amplitude, it's always positive. And then B, this is what determines, I said a second ago, we can have more than one cycle in a rotation. B tells you the frequency. The frequency tells you how many times is there one cycle. Remember, where it doesn't repeat, so one cycle that does not repeat between 0 and 360, or 0 and 2 pi. So if, like what we just did y equals sine theta. So our amplitude for the parent function is 1. Our frequency is 1, which made our period 2 pi, or 360, depending on which one we did. If that was y equals 2 sine 2 theta, there would have been 2 cycles in one rotation. 3 theta, 3 cycles in one rotation. And what happens is that just makes the period get smaller and smaller and smaller as that number gets bigger. And again, as we work these, you will see how that happens. The formula for finding the period is you take one rotation, 360, and you divide it by the frequency. Or if you're in radians, you take 2 pi and divide it by the frequency, the B value. So just by looking at an equation, you can't figure out the period. You have to use the formula to do that. Then we're going to go opposite in a couple days. You're going to be given the graph so you can figure out the period. You've got to use that formula to find the B value so you can write your equation from the graph. All right, so here, y equals 3 sine x. So the first thing it says to do is to state the amplitude. So our amplitude is whatever's out in front. Always positive. If that was negative 3, it'd still be 3. Amplitude is a distance. If it was negative, it would just flip it, reflect over the sinusoidal axis. Then it says state the period. The period has to tell us degrees or radians right now. So the period is 360 divided by B. This is y equals A sine BX right now. So B is 1. So our period is just 360. Nothing has changed. Yes?
Why did you, oh,
Okay. Good. Anything else so far? So I have to do those two things. Now, if I just said graph, you wouldn't have to write them. The reason I'm writing them is because the directions tell me to. Test or quiz me, you might just say graph, but you need to find these things in order to graph. So the next thing to do would be to plot our 5 critical values. Well, there's no left and right shift, so that means we're going to start at 0 degrees and we're going to end at 360. Now, let's say we don't recognize that that's just like what we just did on the 2 parent functions, and we're like, how in the world do we figure out what those points are? Well, all of these are halfway in between. So this one is halfway in between the outside. The middle is actually the middle of the 2 outsides. So 0 plus 360 divided by 2, 180. Then this is the middle of those 2. Halfway in between, 90. 180 and 360, halfway in between, 270. But again, maybe we don't know. Maybe this is 180 and this is 300. How do you figure that out? Add and divide by 2. How do you find the midpoint? Midpoint formula. Add and divide by 2. Now you have to put your y-axis in the correct place. Always has to be at 0. Today it'll always be that first critical value because we're not going to have any kind of shift. Since our amplitude is 3, we know we're going to go up 3 and down 3. We can go ahead and label that. Now, two things right here. You can know the pattern. If you don't know the pattern, then you got to use the T-chart. It is completely up to you. But if you do everything, you'll start to see that these graphs look the same over and over and over again. And if you know the pattern, it's going to be super easy. Usually, students do typically very well in this unit. All right, so let's say I don't remember the pattern. I don't know where sine starts. Does it start at 3? Does it start at 0? Does it start at -3? If I don't know, then just like with anything else, plug in the x value. So I'm going to say y equals 3 times sine of 0 degrees, which equals 3 times 0, which is 0. So I plot that point. Now, if I look at my parent function, I see that after the middle, sine goes high. But if I can't remember that, then I do that again. Y equals 3 times sine of 90 degrees. 3 times 1 is 3. So when I plugged in 90, I get 3. Now, hopefully from this point, you kind of got what's going to happen. You can't ever skip a middle. So we were at middle, high, back to middle, low, back to middle. Notice it looks just like the parent function, except instead of going up 1 and down 1, we went up 3 and down 3. So it's basically a vertical stretch. Now, do you have to put 3 tick marks? I don't care if you do or not. There'll be some that's like 27, and I'd rather you not make 27 tick marks one way, and then the amplitude is 45, so you make 45 tick marks. Just put 27 where 27 is, above 0. This is 0. Positive numbers must be above 0. Negative numbers must be below 0. And notice like my 3 is probably a little higher than my -3. That does not bother me. If it bothers you and you need to measure it out, fine. But I'm just going to look, is your 3 above the 0? Is your -3 below the 0? That's what I'm looking for. All right, then it says domain and range. We are finding the domain of the function. We only graphed one cycle. We can't graph all the cycles. Remember? It keeps going on and on forever. So that's what we're finding the domain of. It never stops going left. It never stops going right. The domain of any sinusoid, sine or cosine, is -infinity to infinity. Always. And then the range, it says interval notation. Be sure I follow those directions. Does have a high and a low value. The low value is -3. The high value is 3. So domain and range for any sine or cosine. Doesn't matter if it's flipped upside down, stretched, shrunk, moved left, right, up, down. The domain is -infinity to infinity. No matter how much we stretch it, it's still going left to right. We move it up, still going left to right. We move it left to right, still going left to right. Flip it upside down, still going left and right forever. That does not change. The range will eventually change because we'll start shifting it. All right, -5 cosine x. So our amplitude, this is where it's important not to say -5. Amplitude is a distance. Amplitude is 5. Our period is 360 divided by b. b is the number in front of the angle. X is the angle, so it's 1. So our period is 360. Now that we've done that for the 4th time, most of you could probably just fill these in. It's what they're going to be when it's 0 to 360. Now, are these the only points on that? No, it's made up of an infinite number of points. I mean, we could pick 1 degree, 2 degrees, 3 degrees, but do we know the cosine of 3 degrees? No. We know the cosine of 90 degrees. We could pick the cosine of 45 degrees, but does anybody know what root 2 over 2 is without like just spitting it out? Probably not. Maybe a couple of you know what root 2 divided by 2 is. Hey, but these are nice numbers that we know. They're the high and the low values. Amplitude is 5, so that means 5 and negative 5. Now, cosine. Again, if we know the pattern, look back at our cosine graph. So cosine, high, middle, high, but it's a negative. So since it's negative, what do you think is going to happen to that high?
It's gonna
Nope. It's going to be reflected over that sinusoidal axis. Let's say if I don't know that, how would I know that? Negative 5 cosine of 0 degrees. Negative 5 times 1 gives me negative 5. That's how I figure it out if I don't remember the pattern. You've got to plug in the values. And then if I'm low, the only option next is to go middle. Then I have to go high, middle, low. And so it's just the cosine graph flipped or reflected over the sinusoidal axis. Yes, ma'am.
How do you know to multiply the 5 by the thing?
I just use the formula, this.
But it's negative 5 times 1, and then last time it was 3 times 0.
Because that's what was given. So this given is y equals negative 5 cosine x. So here are the x's that I plug in. This one, y equals 3 sine x. So I just have to do whatever the problem is. I mean, like, yes?
About the sinusoidal, I can't pronounce that, but the sinusoidal axis location on our notes.
Oh, why don't my notes say that?
It's with the label of the max and min value.
Label the max value, min value, and sinusoidal axis locations on the y-axis. So our max value, yeah, I don't think we'll ever do that. I don't know where that came from. The max value would be 3. The min value, nobody told me that earlier when I was doing these problems. Thank you. And our sinusoidal axis would be y equals 0. And it's not degrees because it's y. So if we were to ask that, I don't think we'll ever ask that on a test or quiz. So don't worry about that. I don't know why that's on there. Anything else on that? Say anything else on your notes that I'm not covering? Label the max and the min. Okay. Yeah, we won't worry about the max. Don't worry about the max, the min, and the sinusoidal axis. All right, sine 2 theta. Now the 2's in a different place. And I think this one says radians on your notes. Okay, so these 3 are going to be in radians. All that means is when we do our period, we use 2 pi over b instead of 360 over b. That's all that we're changing. All right, so first, the amplitude. The amplitude is this number out in front, y equals a sine b theta. So the amplitude is just 1. The period equals 2 pi over b, which is 2. So the period is pi. What that means, remember, b means the frequency, so that means there's 2 cycles in one rotation. So between 0 and 2 pi, there's 2 cycles instead of typically with the parent function, there's just 1. So think about that. If there's 2 cycles between 0 and 2 pi, we want to graph 1 cycle, then it should just be pi. There's 1 cycle every pi. So we go 0 to pi. And why do we always start at 0? Because right now there's no shift. Tomorrow we'll shift, and it won't always start at 0. Then we want to find the midpoints. That one's pretty easy. Halfway between 0 and 1 is a half, so pi over 2, or 1/2 pi, or 0.5 pi, however you want to think of it. I like using the fractions, but as long as you don't round, decimals are fine. Halfway between 0 and a half is a 1/4. And halfway between a half and a whole is 3/4. Or think of it 0.5 to 1 Think of it in quarters, 50 cents to $1, 75 cents, 3/4. Or 1/2 plus 1 divided by 2 equals 1/2 plus 2 over 2 divided by 2. 3 over 2 divided by 2. I can't divide fractions. 3/4. So if it's not something you can do in your head, add and divide by 2. Add fractions, get a common denominator. Dividing by 2 is the same as multiplying by 1/2. Multiply by the reciprocal. Draw our y-axis. Amplitude is 1, so 1 and -1. Now let's do this one just solely off the what the shape is, the pattern. Sine starts middle, positive. It's just the only thing that's different was this x-axis. The graph doesn't change. Okay, this x-axis is the only thing that changed. So it's going to look just like the parent function. It's just we had different values on our x-axis. Now, earlier someone said, but sine of pi over 4 doesn't equal 1. We all know sine of pi over 4 doesn't equal 1, right? But this is not sine of pi over 4. This is sine of 2 theta. So sine of 2 times pi over 4. So if we're plugging in pi over 4, that's our x value, then we get y equals sine of pi over 2, which is 1. So when we plugged in pi over 4, our result, our output, we plugged in pi over 4, we got out a 1. Okay, so just because there's a pi over 2 on this graph right here at 90 degrees doesn't mean it's 1. It all depends on the original function given. Just like y equals x has the points 1, 1, 2, 2, 3, 3, 4, 4. Well, once you do y equals 2x, those points aren't the same anymore. They change depending on the function given. And then domain of any sinusoid, -infinity to infinity. Range is low value up to high value. Cosine of pi over 3x. The period is not pi over 3. Pi over 3 is the b, the frequency. So again, our amplitude is 1. Our period equals 2 pi over b, which is pi over 3. So can you plot 2 pi over 3? No, you can't divide fractions. You have to multiply by the reciprocal. So what do you get for the period? 6 pi? 6?
Oh yeah, you do get 6.
It is 6, correct. Just 6. Pi divided by pi goes away. Can we have just a 6? Yes. We could have 6. We could have 6 pi. We could have 6 degrees. All of those. 6 and 6 pi are radians. 6 degrees is degrees. The way you know this one's not degrees is there's no degree symbol. If this was 360 now, could this be 360 and this be pi over 3? Would that ever happen? No, that won't happen. We won't mix pi's and degrees for you. Doesn't mean it couldn't happen, but we will never do that. So if there's a pi in the problem, you do know radians, but that's not what determines it. What determines it is the horizontal shift, which again today we have none. So the period is 6, so 0 to 6. And then halfway. You like decimals, you like fractions. It doesn't matter to me. I like fractions. I'm going to say 3 over 2. 1.5 is fine. 9 over 2. 4.5 is fine. But if you don't write the correct decimal, now you went from something right to something wrong. I do not care, decimals or fractions, as long as you don't round. If it was 1/3, it would need to stay 1/3. Because 0.3 would not be correct. And I don't want to see a repeating sign. Draw your y-axis in the correct place. Amplitude is 1, 1. Cosine starts high. Our next option is only middle, low, middle, high. And then remember that concavity, that curve in the graph is important. Got to have a little bit of curve to it. If you're confused and you're not sure, like, is my graph good enough? Ask me on homework days. Test and quiz days, it's too late. I'm not going to answer on a test or quiz. I'll answer on your homework. Is this graph okay? Is this how I'm drawing it all right? I'll tell you yes or no. Quiz days, you ask me, is my graph all right? I'm going to say, I don't know. I'll let you know when you get the grade back. Domain, negative infinity to infinity. The range, low value up to high value. The last one has a negative, an A value other than 1, and a B value other than 1. Remember, amplitude is a distance. So amplitude is not negative 3. It is just 3. The distance from the middle up, from the middle down. Not top to bottom, okay? It is the distance from the sinusoidal axis up and from the sinusoidal axis down. Period equals 2 pi over 4. This one could very easily have been degrees or radians with just that 4 there. This does not determine. Only the plus or minus C, which we do tomorrow, will determine. You have to be told. I will tell you, we won't just let you pick. On the test and quiz, it'll tell you what to do. If it doesn't tell you what to do, that means you need to know what to do according to the problem. So that is pi over 2. So 0 to pi over 2. Halfway, pi over 4. Halfway, pi over 8. Pretty easy when this leading number is 0. And then what I think of it as, I see that as 1/8, 2/8, 3/8, 4/8. Or you could have done 1/4 plus 1/2. Get a common denominator, divide by 2. However you see that. Some of you just see that and you know that it's 3/8. If you don't, figure out what the increment is. These increments will always be equal. If they are not, you've done something wrong. Okay? Each of those 5 critical values will always be the same distance apart. Always. And our amplitude is 3, so that's up and down 3. Now, cosine starts high, but it's negative, so that's going to be reflected down low. Then we can just go for the pattern. If we start low, our next choice has to be middle, high, middle, low. And then again, just remember that concavity, curve it correctly. And then you have your domain of negative infinity to infinity, and your range, low value of y up to high value of y.